Hello and welcome. We continue our journey of probability theory, and in this video considering secondary event and the calculation of their probability. Consider two events S1 and S2 from the sigma algebra of the related experiment. Then S1 or S2 is an event where S1 or S2 or both of them are occurring, and is shown as S1 union S2. And S1 and S2 is the event where S1 and S2 occur simultaneously. Not S1 is the event where S1 is not occurring. These events are secondary events generated from S1 and S2. The intersection of two events S1 intersection S2 is an event which occurs when both S1 and S2 occur. For example, if S1 is 2 and S2 is 4, then the probability of S1 intersection S2 is the probability of empty set, which is 0, because 2 and 4 in the experiment of tossing a dice do not occur at the same time. The union of events S1 union S2 is an event which occurs if S1 or S2 or both occurs. The probability of S1 or S2 is the probability of S1 plus probability of S2 minus probability of S1 and S2. Again, consider S1 to be 2 and S2 to be 4. The probability of S1 union S2 is the probability of S1 plus probability of S2 minus probability of S1 and S2. From the past lectures, we know that the probability of 2 is 0.163 and the probability of 4 is 0.168. And probability of S1 and S2 is 0. Therefore, the probability of S1 or S2, in other words, getting 2 or 4 is 0.331, in other words, 33.1%. The complement of the event S1 is when the event S1 is not happening, or the event where S1 is not happening. Probability of the complement of S1 is 1 minus the probability of S1. For example, if S1 is 4, then the complement of S1 is the event where we do not get 4. That means we either get 1, 2, 3, 5, or 6. And the probability of the complement of S1 is 1 minus probability of S1, which is 1 minus 0.168, which is 0.832, which is 83.2%. In other words, the probability of not getting 4 is 83.4%. Consider again the experiment of tossing a dice and the Monte Carlo simulation results, which are presented in the following table. And suppose that S1 is 1, S2 is getting 2, and S3 is a number less than 3. Less than 3 means either 1 or 2. Then the probability of S3 is probability of S1 or S2, that is getting either 1 or 2, which by formula of the union is the probability of S1, probability of S2 minus probability of S1 and S2. Since 1 and 2 cannot occur simultaneously, this probability is 0. These two probabilities we know from the distribution table, which is 33.1%. We can get nearly the same result using the number of elements in S. Probability of S3 is probability of S1 union S2, that is the number of 1s and 2s in S, divided by the total number of elements in S. The total number of elements in S is 6, we know that. And if we combine the number of 1s and 2s in S, we get 2, because we have 1, 1, and 1, 2. Together we have 2, 1 over 2. 2 over 6 is 1 over 3, which is 33%, which is nearly the same probability we got from the Monte Carlo simulation. Thank you for watching and see you in the next video.